In this lesson, we're going to talk about parallel and perpendicular lines, and we're going to be relating both parallel and perpendicular lines to each other through several different theorems that we're going to talk about. And the first one, our focus question is, how are parallel and perpendicular lines related? Well, this first theorem says that if two lines are parallel to the same line, then they're parallel to each other. It's kind of a transitive property. And so in this case, if we have A parallel to B and B is parallel to C, then we can say A is parallel to C. Our next theorem says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So for instance, if we have line M being perpendicular to line T, and if N is also perpendicular to that same line, then we can conclude that M and N are parallel to each other. Here's a proof of that theorem, just a quick proof. So if we are given that R is perpendicular to T and S is perpendicular to T, so here is line T right here, and these two lines are both perpendicular to that line, we want to prove that R and S are parallel. Well, we can start off by saying angle 1 and 2 are right angles, and that's the definition of being perpendicular, means that it forms right angles. We can also say that angle 1 and angle 2 are congruent. Since they are both the same measure, they're both 90 degrees, they are congruent to each other. And then we can say, well, 1 and 2 are corresponding angles. And we also know that if we have two angles that are corresponding, that are congruent, then their lines must be parallel. So we can conclude then that R is parallel to S. Here's a carpentry problem. It says a carpenter plans to install molding on the sides and the top of a doorway. He cuts the ends of the top piece and one end of each side of the pieces at 45-degree angles as shown. Will the side pieces of molding be parallel? So if we put this together, will these two side pieces, will their edges be parallel? Well, actually, yes, they will. When you put those together, those two 45-degree angles form right angles, so we have 90-degree angles at the corners. And so if those corners are right angles, each side is perpendicular to the top. And if the two lines of the sides are perpendicular to the same line, like we just said in the last theorem, then they must be parallel. So the sides will be parallel to the top. So here's one for you to try. Can you assemble the pieces at the right to form a picture frame with opposite sides parallel? Well, if you can imagine rotating these 30-degree angles and fitting this side here to this side here, we will indeed have 90-degree angles, and this one over here would go on the left side, and then we have the top and bottom, and they would fit. And it's going to be the exact same scenario as we had in the problem above. They will form right angles, and if they form right angles, they're perpendicular, and if two are perpendicular to the same side, then they must be parallel. So it's the exact same reasoning. So those two theorems that we just talked about, they give us conditions that help us conclude that lines are parallel. This theorem helps us conclude that lines are perpendicular. So it says in a plane, if a line is perpendicular to one of two parallel lines, then it must be perpendicular to the other. So if we have line N right here is perpendicular to L, and we know L and M are parallel, then it's going to be true that line N will also be perpendicular to line M. And I don't know if you recall, but when we did our sketchpad activity, we showed that this was true. So the perpendicular transversal theorem, one of the things you need to be aware of is that it says in a plane. That's a very important phrase, in a plane, because if we're talking about 3 dimensions, when we're in different planes, this theorem does not hold true. So if you think about in a rectangular solid, it says line AC and line BD are parallel. EC right here is the vertical one, is perpendicular to AC, but it's not perpendicular to BD. And if you recall, it's actually skew. So this theorem does not hold true unless you're in the same plane. So I just wanted to point that out. So here's a problem for us. It says in a plane, so we're in a single plane, C is perpendicular to B. So this line here is perpendicular to B, and B is perpendicular to D, and D is perpendicular to A. We want to prove that C is perpendicular to A. So is line C at the top here perpendicular to line A? If we were to extend those, and they would intersect? Well, our givens are stated first, those three perpendicular lines to each other. So our next step would be that C is parallel to D. C and D must be parallel because they are both perpendicular to the same line. And then we can conclude that C is then perpendicular to A because of the perpendicular transversal theorem from the last page. In problem 2, could you also conclude that A is parallel to B? Well, that's going to be the same kind of reasoning. Yes, we can, because they are both perpendicular to D, and in a plane, if two lines are perpendicular to the same line, then they are parallel. Here's a lesson check for you. Please work on these two problems and bring your answers to class.